Kia ora, Year 11 and 12. Here's question 1c from last year's Level 2 Calculus paper. So this time this is an anti-differentiation question and one about a turning point. So again, if you're watching this and you're in this year's maths class with me, we haven't done this yet, feel free to try and make sense of it anyway. So here we're given the derivative of a function. So we're given the gradient function, and it's a quadratic, it's a parabola, and we're told that the graph of the function, which means the graph of f of x, has got a local minimum at the point 0,5. So use calculus to find the value of the local maximum of this function. So half a minute's thinking will tell you that if the gradient function is a parabola or a quadratic, f of x is going to be a cubic. And in this case it's going to be a negative cubic, so it's going to have this shape. And so this here, this is my local minimum, and we know that that's at 0,5, and we're looking for the value of the local maximum of the function. So what does the value of the local maximum mean? Well, it means that I'm going to get two coordinates, and the value of the function is the y coordinate. Okay, so let's start off by going, well, how do I go backwards? So we're differentiating backwards, and we do that using this lovely integral sign. Again, if you're watching this and you haven't done this yet, don't freak out. All we're doing here is we're working backwards from the gradient function to the original function. So that's going to give me negative x cubed plus 6x squared plus some constant, right? This is called the constant of integration, and this is shifting me up and down my family of cubics, right? So they've all got the same gradient, but they're translated up and down. So we're going to have to use some information, in fact this information, the 0.05, to figure out what c is. But I'm getting slightly ahead of myself. So we've got our function, and there's two things we can do next. We can either straight away figure out the c, or we can go back and look at the gradient function again. Right, but I think I'm going to get on with it and find the plus c. So we know that 0,5 is on the curve. So we can substitute this point into here and get the following. 5 is equal to negative 0 cubed plus 6 times 0 squared plus c. That gives me that c is equal to 5. So my function, f of x, is equal to negative x cubed plus 6x squared plus 5. So we're going to park that for now, and we're going to use that again at the end of the question. Right, let's go back and have a look. We have to find the value of the local maximum of the function. Now we know the local minimum is at the point 0,5. We've seen informally in class already that we have a zero gradient at the turning points. So to find the local minimum and the local maximum, we take our gradient function and we set it equal to 0. So we've got f dash of x is equal to negative 3x squared plus 12x. And so that equals 0 for a local min or max. So we're going to solve this easy quadratic. We get negative 3x times x minus 4 equals 0. So x is equal to 0, or x is equal to 4. We've already found or been told that this one is the local min, right? So we know that's on the curve. So what we're going to do now is to say that this one is going to give us our local max. Right, now how can we justify that? Well, there's several ways. We're going to come back to that. The first thing we're going to do is to say what is the value of the function at x equals 4. And we've found that f of x is equal to negative x cubed plus 6x squared plus 5. So when x equals 4, this function is equal to negative 64 plus 6 times 16 plus 5. Chuck that in your calculator and you'll get 37. So this is the value of the local max. But the last thing I want to talk about is how we can justify that this is a maximum. And the work we've done this year on level 2 graphing really helps us here. So let's have a look at our function. Well, it's a cubic, and it's a negative cubic. So we can use this at level 2 to justify which one is a min and which one is a max. So the shape of the cubic goes like that. No, that's a positive cubic. Right? And our one is a negative cubic. So this is the case we've got here. By a negative cubic, I mean that we've got negative x cubed for that first coefficient. So this point here is x equals 0, and this next one is going to be x equals 4. Now there are two other ways to justify that we've found a maximum. The first of these is to work out the second derivative, and then work it out at x equals 4. Okay, so let's just back up. F dash of x is what I'm going to have to differentiate again. Now you weren't actually asked to justify this in this question, but it's usually a good idea to. So we can differentiate that again, and we get negative 6x plus 12. And now we can work out the second derivative when x is equal to 4. So that equals negative 24 plus 12. So that's negative 12. And that's less than 0. So that means that we have found a local maximum. I'm going to talk more in class about why that is, and I'm not going to go any more into that now. But the second derivative test is the easiest way in calculus to show that we've found a local maximum. The last way that I could do it is I can look at my gradient function, and I can take the point that I'm interested in. So we can take x as 4, and then we can look at points on either side of it. So we can look at 5, and we can look at 3. And we can ask, what's the sign of the gradient at those different places? So at 4, the sign of the gradient is 0. And at 5, if you work it out, the sign of the gradient is positive, and at 3, it's negative. No, that's not right. We're the wrong way around. If I had that, I would show that we had a minimum here. So cancel that. I'm not going to redo the video, which is what I usually do when I screw up, but I've got too far through this one. So here, if we take 5 and we work out f dash of 5, we're going to get what? Well, we'll get negative 75 plus 60, which is negative 15. So that's negative. That means that I've got this situation. And then if I put in 3, I'm going to get a number for my gradient function, which is positive. Okay, so I'm basically tracing out here a maximum, and that's the other way to do it. So that's 3 ways that we can justify that we found a maximum. The first way, which is going to feel like a black box for now, is the second derivative test. Now that's usually the easiest, but you've got to remember what we're looking for. So to find a local maximum, we need to find a negative second derivative. The second way, which is okay at level 2, is to use what we're working with, which is a cubic, and to say, this is the picture of a cubic. I've got a negative cubic, so the first of the 2 roots is going to be my min, and the second is going to be my max. So that's method 2. And then method 3 is this thing where we look at the gradient on either side of our point and figure out what we've got from that. This is pretty thorough, but it takes this one here, the third one, but it takes a little bit of time. Okay, so I'll be back soon with both of the excellence questions in question 1.